Hello students. We are discussing the states of matter. So, before that, let us revise what is matter. Do you remember that? Yes, the one that occupies space and has mass is called matter. Now, based on all the physical properties, it is divided into 5 different states of matter. Right? What are those? The first one is the solid state, the second is the liquid state, the third is the gaseous state, the fourth is the plasma state, and the last is the Bose-Einstein condensate. In this particular module, we will be studying all these. So, without any delay, let us start our module. As you can see, we are analyzing solid, liquid, and gas together. So, the first property we will discuss is that they have intermolecular forces. Solids have very strong intermolecular forces. Now, the intermolecular forces are comparatively lesser when it comes to liquids, while when it comes to gases, their intermolecular forces are very, very low. The next one which we have to discuss is the interparticle space. In solids, the interparticle space is very little. It is more in liquids and maximum in gases. So, based on these two properties, we can actually understand their other properties as well. So, let us see the next property, which is mass. When I talk about any state of matter, remember that matter will always have a definite mass, no matter which state you consider. The next thing is shape. When I talk about shape, solids have a definite shape because of the strong intermolecular forces acting between the particles. On the other hand, when it comes to liquids or gases, they will occupy the shape of the beaker or the container in which they are in because of comparatively lower forces of attraction acting between them. Now, the next one is the volume. As you already know, when it comes to solid and liquid, they have a definite volume, right? When it comes to gas, they do not have a definite volume. They will occupy the whole space around them. Now, the next one which we have is compressibility. To discuss is about compressibility means the ability to compress. So, when it comes to solid, they are very rigid. While compressibility, when it comes to liquid, is negligible. On the other hand, gases are highly compressible. The next one, which we have to discuss, is fluidity and rigidity. What is fluidity? Fluidity means the ability to flow, and opposite to that is rigidity. Solid being very rigid cannot flow. In contrast, when it comes to liquid or gas, they can flow. The last one is diffusion. So, what is diffusion? Diffusion is the ability to spread. The ability to spread is very low when it comes to solid. It is better in liquid and is maximum in gases. The next one is the plasma state. So, what happens in plasma? For this, let us take an example of a star. So, when I am talking about a stars, what temperature will it have? It will have a high temperature, above 1000 degrees Celsius. Correct? So, at that time, what happens is that the particles in the gas, that is, atoms or molecules, will be ionized at that temperature, implying that there will be ionized gases and free electrons. Now, these two are opposite charges. So, these opposite charges will be attracted towards each other through electrostatic force of attraction. Because of that, they will show an increase in their fluidity. And also, due to the presence of charged particles in them, they will also be good conductors of electricity. Now the question is, does this only exist in stars and the sun? The answer is no. We can also create this on the earth. So, The plasma state is present in neon signboards, tube lights, plasma TVs, auroras, and likewise. Actually, anything that glows. So, remember that. Now, after plasma state, let us talk about the Bose-Einstein condensate. The Bose-Einstein condensate can also be written as BEC. So, this is actually the opposite of the plasma state. That is, it is seen at extremely low temperatures. Over here, we are taking a gas that is in a supercooled state. Here we take a gas that has very low density. Actually, the gas which is taken over here is 1 millionth time the density of air. Now, what we will do is, we will decrease its temperature. So, let us say that it is at T Kelvin. When under controlled conditions, we decrease the temperature, and the particles will remain in the gaseous state only. Now, this decrease in temperature is till the point which is very close to 0 Kelvin. Wait. So, what is 0 Kelvin? 0 Kelvin is minus 273.15 degrees Celsius. So, it is very low temperature. Correct. So, now what will happen over here is that the gas will be condensed. So, because of that, its fluidity again changes. This supercooled, very low dense gaseous substance is now considered to be BEC. You will wonder why this name. Because this particular state of matter was discovered by Bose in 1920 based on the calculations which were done by Einstein. So, after studying the different states of matter, let us see why they exist in different states of matter and how they are interconverted. So, there is the kinetic theory of matter, which explains how the states of matter exist. So, over here, what are the postulates? According to this theory, the state of matter is dependent on the interparticle force, and it is also dependent on temperature. Okay. So, if you increase the temperature, what will happen? The interparticle attraction will decrease, and they will go into another state. And if you decrease the temperature, then the attractions will increase. Why is it so? Because temperature is directly proportional to kinetic energy. As you increase the temperature, the kinetic energy will also increase. With the increase in kinetic energy, the particles will vibrate more. As they vibrate more, they will break the interparticle forces and decrease the attraction level. Then they will change into another state. Now, when I am talking about the three main states of matter, the strongest forces are seen in solid. Next is liquid, then gas. Now, as we are done with all the states of matter, let us conclude what we studied. First, we studied all the different states of matter. There are 5 different states of matter: Bose-Einstein condensate, solid, liquid, gas, and plasma. Then, we saw the comparative properties of solid, liquid, and gas, which are mainly dependent on the intermolecular forces. Then, we moved on to the plasma state, which is ionized gas at high temperature. And then, we saw BEC, a supercooled gas with very low density. Finally, we studied the things responsible for the state of matter through a particular theory called the kinetic theory of matter, which is temperature dependent. So, that is it in this particular module. I hope you understood and learned from this. Thank you.